I'm Chris Ryder. I'm Director of the EPSRC Centre for Innovative Manufacturing in Large Area Electronics. I'm based in electrical engineering at the University of Cambridge. I work with partners at Imperial College London, Swansea University, Manchester University and other colleagues at Cambridge. Large area electronics is really a new way of making electronics. It's enabled by several new classes of materials such as organic materials, metal oxides and carbon-based materials, which would include graphene, carbon nanotubes and related materials. And the benefit of these materials is that you can process them to make electronic devices at low temperatures, which means you can put the electronics down onto plastics like polyester and paper and things like that, which you don't normally find as substrates for electronics. And if you've got electronics down on these flexible substrates, it means you can use and deploy the electronics in totally new ways. So you can wrap them around curved objects. Not only that, you can make inks out of them, which means you can think about printing them. So you've got approaches which can get the cost of manufacture right down, which can also take us into applications which you can't do with conventional electronics. A lot of companies in our sector have tended to focus on one innovation, which they do really well, but there haven't been so many who've been putting all the different elements together to make a system. So we decided to try and help the growth of our emerging industry, that we would focus on system integration challenge and try and do that in a way which makes it easy and high yield. So we have two flagship projects which we're using to drive forward the technology of system integration within our centre. And I should say that system integration also includes integration of large area electronics with conventional electronics. So one of our demonstrators is a sensor system with an array of 16 sensors, and we're going to print the amplifier right next to all the sensors, which has very significant commercial benefits in doing that. And then we'll link that with a conventional silicon back end, so it'll have a microprocessor, a radio, and there will be some power electronics as well. So that's one of the demonstrators. The other one will be made using a conventional contact printing press, and we're going to make an energy harvesting system to harvest radio frequency energy, which can then be used to store and then power electronics. The UK has been a pioneer in the field of large area electronics for 25 years. We have many world-class academic groups active in the field, and a lot of companies have been spun out of this activity. We also have several very large materials companies active on a global scale, and they're wanting to see our emergent industry grow so that the demand for these materials will grow. A lot of the companies that are interested in manufacture are now moving towards pilot scale and thinking about how they're going to manufacture in volume. So one of the great things about our industry being an emergent industry is that we're starting to see the chance of getting some electronics manufacturing in a new area back into the UK. To find out more about our centre or about large area electronics, please visit our website, which is at www.largeareaelectronics.org. Another thing you may care to consider is coming along to our annual conference, and you'll find more information about that on the website, and there you'll get a chance to meet not only the academic community but also the industrial community and representatives from the High Value Manufacturing Catapult Centre.